Hey, we're looking at the back page of the 4345 morning quiz review. This is a velocity graph particle motion problem. A particle moves horizontally, so that its velocity at time t for t values between 1 and 15 is given by a differentiable function. The velocity is given, so we're looking at the velocity function here. Velocity is 0 at 2, 4, and 10, and 14, and the graph has horizontal tangents at 3, 7, and 12. Horizontal tangents. So the area of the region is given as 1, 2, 14, 6, and 3 respectively. Now these are areas, so the definite integral for portions that are below the x-axis or below the axis will be negative. So I'll have this as 1, negative 2, 14, negative 6, and 3. Okay. And we're given that x of 1 is equal to 3. So we have a starting point here. Okay, create a sign line for v of t and a of t. So for velocity, we know that the particle is moving to the right if it is above the x-axis. If it's below the x-axis, then we know it's moving to the left. So we know this portion is moving to the right, so I'll call that positive. Left or negative in the negative direction. Positive, negative, and positive. So we're just looking at where the location of the graph or velocity is, whether it's above or below the axis. Okay, sign lines for acceleration. Okay, now the critical points for acceleration is going to be at where the slope is 0. So these are when the acceleration is 0. In other words, second derivative graph, we can think of it as points of inflection at 3, 7, and 12. Now, the slope, if the velocity is becoming more negative, then that's when the acceleration is negative. So this is a negative acceleration here. From 3 to 7, the velocity is becoming more positive, so therefore positive acceleration, a negative acceleration here, and then positive acceleration there. Okay, what interval is the velocity negative? So velocity is negative. We can simply look at our sign line here from 2 to 4 and from 10 to 14, and then justifications because our velocity is negative, less than 0. What interval is acceleration positive? So acceleration is from 3 to 7 and 12 to 15, and justification is acceleration is positive or greater than 0. Okay, for D, on the interval from 3 to 4, the speed of the particle, is it increasing or decreasing? So from 3 to if we're trying to determine whether speed is increasing or decreasing, we compare signs between velocity and acceleration. Opposite signs would mean decreasing speed. Same signs, right, either both negative or both positive, would indicate increasing speed. So between 3 and 4, if we look between 3 and 4 here, 3 and 4, this is negative velocity. Between 3 and 4 is positive acceleration, so opposite signs. That tells us that the speed is decreasing, since velocity and acceleration have opposite signs. Okay, from 10 to 12, is the speed increasing or decreasing? So 10 to 12, we look at 10 to 12 as negative velocity. From 10 to 12, it is negative acceleration. So looks like they pair up to have the same signs. So because they have the same signs, increasing speed since they're both negative. Okay. All right, part F, find the position of the particle at t equals 2, t equals 4, 10, and 14. Okay, we're going to use this formula here. If I want to find a final position or any position I'm looking for in the problem, it's always the initial position, or in other words, the given position. Okay, not necessarily the starting point, the given position plus the displacement. So let's look at what's given to us. We're given that x of 1 is equal to 3, all right? So I'm trying to find x of 2. So x of 2, and let's say I start at x of 1. So to get from x of 1 to x of 2, my displacement is going to be the definite integral from 1 to 2 of velocity. So my equation is now to find x of 2 is my starting point plus the displacement from 1 to 2. And if I look, the displacement from 1 to 2 for this velocity function, I'm going to travel a distance of 1 unit. So integral from 1 to 2 velocity is 1. I know x of 1 is equal to 3. That's given to us. So 3 plus 1 is equal to 4. Right, if I want to find x of 10, I can go back and use x of 1, but we do have x of 2, so maybe that will be a little bit faster to get to 10. So if I want to get to x of 10, which is my final position now, my given position or my known position, I have another known position now, which is x of 2. So if I'm starting at x of 2, and if I want to get to x of 10, I just have to find the displacement of the velocity from 2 to 10. So if I add up these displacements here, negative 2 plus 14 is going to be 12. So the definite integral from 2 to 10 is just going to be 12. Okay. And then so negative 2 plus 14 is 12, and then plus my initial position, or my given position that I found from before, which is 4. So 4 plus 12 is 16. Okay. If I want to find x of 14, my final position, my given position is now I can use the previous statement. So x of 10. So to get from x of 10 to x of 14, I'm going to have to take the displacement of the velocity from 10 to 14. So 10 to 14, I'm just traveling backwards 6 units here. So minus 6. So my initial is 16. So 16 minus 6 equals 10. All right, state the absolute extrema. So absolute extrema, this is extreme value theorem problem, where we have to test the critical points and the endpoints to determine which has the highest value or lowest value. Because this function is continuous, so we just have to test critical points and endpoints. So looks like we've tested most of the critical points, which are at 2, 4, 10, and 14, and then we also have to test the endpoints, which is 1 and 15. So so the thing that's missing is x of 4, so let's go ahead and find x of 4. To find x of 2, I'm going to start off at x of 2, and then displacement from 2 to 4, so that gives me, so if we look at the graph, that will give me negative 2, so 4 minus 2 is 2, and then 15 is just the displacement from 14 to 15 plus x of 14, so that's 3. We see that this is 3 here, so 3 plus what we found from x of 14, which is 10, so that's equal to 13. Okay. So we have the endpoints, which is x of 1 and x of 15, and then we can just compare with all these values here. So 4, 16, 10, 2, 13, and 3. The highest value is 10, and the lowest value is, highest value is 16 at t equals 10, and the lowest position is 2, which is at time t equals 4. Okay, h, find the total distance traveled. So total distance is just the absolute value of the velocity. So we basically convert all these to be positives and add them together. So 1 plus 2 plus 14 plus 6 plus 3, and that gives us 26. Find the total displacement. So total displacement is where we keep track of backtracking. So we keep the negatives in place. So negative 2, from 2 to 15, it will be negative 2 plus 14 minus 6 plus 3, which is 9.